When we see a situation where we don't know the mean, the population mean, and we also don't know the population standard deviation, we now have the tools to still express our estimate and our confidence interval for that situation. So we can still take a sample and build that confidence interval. So let's say, for instance, we are interested in the average income. What is the average income of households in our community? And we don't know the mean. That's what we're interested in, but we also don't know the standard deviation. So we can take a sample, and so let's say we take a sample of 25 families. Again, we're choosing that. We're choosing n equal 25. And we find an average of, let's say, 64,000. We'll just keep it a nice round number for our purposes. Let's say it falls right at 64,000. Now, we also in the process, so that's our x bar. In that process, we will also have 25. We have 25 observations, and we can calculate an S from that. So let's say our S is our sample standard deviation is 8,000. Okay. Now that is enough to build out our confidence interval. So we are going to say our best guess is 64,000 plus or minus. Now remember, we're going to use a t-distribution. We're using S in place of sigma, and because of that, we need this kind of fatter distribution in the t-distribution. And then remember, of course, we are picking the specific t-distribution based on our sample size. So as the sample size gets bigger, the t-distribution tightens up and becomes more like a z-distribution. So at 25, it actually won't be quite as clean, or it won't be that close to the z-distribution. All right, we'll see some difference. And so let's go ahead and plug this in. So we'll take it a step further. 64 plus or minus t, we'll leave that for a second. And we have, what did we say? We had 8 and the square root of 25. So we now have to make the decision if we want a 90% or a 95% confidence interval. Let's stick with the 95% because we'll be more comfortable comparing it to the z-distribution. So let's say we want a 95% confidence interval. We now are going to turn to the t-table rather than the z-table. But for the same purposes, we want to make that switch between percentage and what the t-value is. So I've pulled up the t-table here. Again, you can find this on the website or in your book. So the t-distribution, it's laid out slightly different than the z-table. Okay, the t-table I should call. So confidence interval here. That's what so this has a few different uses. So we use this in our confidence intervals. We're also going to come back to this when we think about hypothesis testing in a couple chapters. Okay, so there's a lot going on here. But for the confidence interval, notice that it's measuring the distance, or it's measuring the area in between t and negative t. Okay, so we're going to get a value of t, and that's going to be, that double-sided value. So as we scroll down here, we want to focus on the confidence interval, this first set of values here. Later on, we'll cover the one-sided and two-sided tests, and we'll use the same information. But for here, confidence intervals, what we want is the 95% confidence interval. And next, we need to go down into the table and find which row we use. Now, the rows we use are based on degrees of freedom. And if you recall from the book, the degrees of freedom for us is equal to, so degrees of freedom in this case is n minus 1. So it's our sample size minus 1. So in our case, that is 24. Now, so let's scroll down. We'll scroll down to the row of 24 here. And we'll have to remind ourselves which column. So we're in this column. So we find 2.064. So our t value is 2.064. And that, as we can see, differs slightly from the 1.96 that we're accustomed to with the z distribution. So this is a slightly fatter. It's going to lead to a little larger of a confidence interval than if we were using the z distribution. And that, again, makes sense when what we're doing here is we're building in a little more uncertainty because we're using S as an estimate for sigma. And you can see, just as we, if we had a smaller sample size, this t value gets larger as we go up and we have a smaller sample size, right? So all up here, if we only took a sample of 5, we'd have a much larger t value, and that would lead to a wider confidence interval. And as we go, just to look around this table a little bit, it goes down to 35, we jump back over and can continue down, and hopefully the second page is here. Yes. So as we keep going, here's 71. We come over here, and by 200, we are pretty close to the z distribution. And in fact, here, when we just write infinite, it becomes the d. Sorry, I'm on the wrong column. It still becomes the z distribution. So 1.96 we see show up there. So it does take a little time to get used to reading the t table, just like it did with the z table. But that's how we go about it. We want to find what confidence interval we want and scroll down to the degrees of freedom, which again is n minus 1. So you can see if we had chosen a 90% confidence interval, we'd have a different value, just like we would with the z. It would become, we'd plug in 1.71. Again, that's a little smaller of a number because we're less certain about it because we're only using the 90% confidence interval. So we can plug in 2.064. So our t distribution, our confidence interval becomes 64 plus or minus 2.064, and then it was 8 over 5. And so, and that's going to give us, again, a window of 2.064 times 8 divided by 5 is 3. This is 3.26 roughly. Okay, so I've dropped the thousands here. We're in thousands, so our actual value here is 64,000 plus or minus 3,200, and I guess technically it would be 264. 4 here. Might as well bring that along. So that would be our confidence interval in terms of the average income of our community. And so we still can get to the same result, same structure, same concept here with a best guess, an estimate, 64,000, and a confidence interval built around that. It's just that we're able to do that with our sample standard deviation and the t distribution.